Hello students. So let's start with the next balancing reactions. I hope you have done the first two reactions and you would be super excited to check the answers. So let's see how exactly this could be done. Okay, now over here again we start with the first rule. The first rule says that you need to balance the polyatoms only if they occur in both reactant as well as product. So over here now if I check, I have a polyatom that is SO4. Okay, it is there in the reactant, but just check, is it there anywhere in the product? Okay, then no, it's not there. Now the most common mistake over here is that SO3 is there, but then my dear students, please understand that SO3 was with a charge of -2. Only then it would be referred as a polyatomic ion. Okay, otherwise it's a compound. So over here SO3 is not a polyatomic ion, it is a compound, and definitely it won't be treated as a polyatomic ion. So the only polyatomic ion which satisfies our purpose is SO4, but then the problem is that SO4 is there in the reactant but it's not there on the product side, so I won't consider it. So let's go with the next rule. The next rule says that you need to start with metal. Okay, then you need to start with non-metals other than hydrogen and oxygen. In this case you have a non-metal other than hydrogen and oxygen, and that is sulfur, and then finally you would be starting with oxygen. So let's not waste any time and let's simply dive into balancing what exactly are the reactants and what exactly are the products. So let's start with the reactants. How many Fe on the reactant side? You have one Fe on the reactant side. So reactant side one Fe. The product side you have two irons, so 2 over here, and therefore definitely I will multiply this thing with 2. 2 comes over here. Let's go further. Now understand something important. Okay, how many sulfurs are there on the left hand side? So I need to multiply this 2 with the sulfur also, because that 2 is for entire FeSO4 and not just for iron. Okay, I can't just multiply 2 with iron and not with sulfur if they are a part of the same compound. I can't do that. Okay, so this 2 is there with sulfur as well. So how many sulfurs? 2 on the left hand side. On the right hand side again I have 2 sulfurs. Very good. So definitely there is no problem. Sulfur are balanced. Let's go ahead. Next, oxygen. So over here 2 4s are, so 2 4s are is 8. Now why I'm doing 2 4s are? Because see, this 2 would be multiplied with oxygen, but then how many oxygens are there? There are total of 4 oxygen atoms, and therefore you have total 8 oxygens. So hence the total 8 oxygens on the left hand side. Let's write understanding on the product side. So 3 over here, 2 over here, 3 plus 2 is 5, plus 3 is 8, and yes, the reaction is balanced. Okay, so what was the final balanced equation? Over here I can just write the final balanced equation as 2FeSO4 gives, I'm not putting in the state symbols, okay, right now, gives Fe₂O₃ plus SO2 plus SO3. Now SO2 and SO3 both are gases, so obviously I'm not putting the state symbol, but then I'm putting it with a arrow sign. Okay, let's go ahead with the next one. Now the next one is BaCl2 plus Al2SO4 thrice gives AlCl3 plus BaSO4. Important, listen carefully. Okay, let's start. So again we'll start with first is polyatoms. Polyatoms, just check if you have any polyatoms. Then yes, I do have a polyatom, and this time around it is the sulfate polyatom. Okay, so I would start with sulfate, that is SO4. Okay, and why I'm doing SO4? So because it is in the reactant side, also on the product side, so I can start with SO4. So the first priority would be for SO4. The next point is balance the metal. Now over here, if you check, barium is a metal Aluminium is also a metal. So a question might come as to whom should we start with. Doesn't matter. You can start with any metal. Okay. Some might feel that, okay, we'll start with barium. It's fine. Some might start with aluminium. Even that's fine. Absolutely no problem. So over here, let's say we started with barium. Then comes aluminium. Okay. Next one is you need to balance all the non-metals other than hydrogen and oxygen. So over here, do you have any other non-metal except for hydrogen and oxygen? Then yes, we do have a non-metal, and that non-metal is chlorine. So the next priority would go for chlorine. Finally, we have the next point which says balance the hydrogens. But then you don't have any hydrogen in this reaction. So obviously there comes no question of balancing the hydrogen atoms. Next is balance the oxygen. But then the problem is, or not a problem, I won't say it is a problem, but it's a good part. Okay, the good part is that the oxygens are already part of SO4 and you don't have any other oxygens in the reaction. Okay, see, you don't have any other oxygen except for SO4, right? So the only part that I need to take care is of SO4, and that's already taken care of in the first priority, right? So now we are only left with our last job, that is to find how many in the reactants, how many in the products. So let's see. So you have reactants, you have products. SO4, how many in the reactant side? Just check. So I have SO4. And this SO4 is repeated how many times? It's repeated 3 times. So how many SO4s on the left hand side? You have 3. How many SO4s are there on the right hand side? There is only one SO4. So over here you have only one SO4. Okay. So definitely what I need to do is I need to multiply this thing with 3. So I'll put a 3 over here. Okay. Let's go ahead. How many bariums on the left hand side? Now over here on the left hand side, I have only one barium atom. Okay, but on the product side, because we have just multiplied it with 3, I have 3 bariums. So definitely I need to multiply with this also. So 3 comes over here as well. Let's go ahead. Now the task comes for aluminium. Aluminium, how many on the left hand side? So you have 2 aluminiums on the left hand side and only one aluminium on the right hand side. So again, we need to multiply this thing with 2. So we'll put 2 over here. And finally, let's talk about chlorine. Chlorine on the left hand side is 3 2s. So 3 2s is 6 chlorines. And on the right hand side is 2 3s. So it's again 6. And now my reaction is finally a balanced reaction. Okay, let's write down the reaction once again. What is the final reaction? The final reaction is 3 BaCl2 plus Al2SO4 thrice gives, I'll just write it down, okay, gives 2AlCl3 plus 3 BaSO4. And just check, BaSO4 is with a downward arrow. That means this has been precipitated. This has been precipitated. We will learn more about it, don't worry. So this has been precipitated. It is converted into solid. So this was in the aqueous state, even this was in aqueous state, even this was in aqueous state, but then this is in solid state, and that too it is insoluble. So that's the reason it is coming with a downward arrow. Okay, let's go ahead with the next one. That is the last reaction for balancing. An important one, a very important one. Okay, let's try to understand how exactly do we need to balance this. So once again, the rule is you start with polyatoms if they are in both reactant as well as product. Not there is no polyatom which is there, so definitely that rule goes null and void. You start with a metal, again you don't have any metal, carbon is a non-metal, so you don't have any metal, so again that rule goes null and void. So you start with a non-metal, the non-metal other than hydrogen and oxygen, that's only carbon in this case. And finally you will start with hydrogen, then oxygen. We need to check how many of them are in the reactant side, how many of them are on the product side. So let's start. Okay, so let's start with carbon. Carbon over here, how many on the reactant side? So reactant side you have 2 carbons, product you have 1. So definitely multiply this thing with 2. Put a 2 over here. Carbon is balanced. Let's start with hydrogen. How many hydrogens are there on the left hand side? So you have 6 hydrogens over here and 2 hydrogens over here. You can just check 2 hydrogens over here. So we need to multiply this thing with 3. So put a 3 over here. Okay, this is again balanced. Let's go ahead. How many oxygens on the left hand side? So oxygens are 2 on the left hand side, and on the product side, if you just notice, 2 2s is 4 and 4 plus 3. Okay, because there is 1 over here, so 3 1s is 3. So 3 oxygens on this side, 4 oxygens over here. So total becomes 7. Okay, now comes a problem. What problem do we have? So I can't multiply anything with 7 to make it 2. Okay, nor I can multiply anything with 2 to make it 7, which is a whole number. I can have a fraction, but then do you remember our points of balancing? It clearly says that no fractions are allowed. Okay, so definitely what I'm saying is that you can't have a fraction over here, and that's the reason why I'm saying that you don't have anything, any whole number which is common between 7 and 2. So what I can do? Now let's try to understand. Okay, important, again I'm saying listen very carefully. Okay, let's see. So I have two options over here. The first option is I would multiply 7 with 2 by 7, so that 7 and 7 gets cancelled off. 2 becomes equal to 2. This is my first option. Okay, the second option that I can have over here is I would multiply 2 with 7 by 2. So 2 and 2 would get cancelled off. 7 will become equal to 7. So what is my first option? Once again, let me rewrite it for you. Okay, so what is my first option? My first option is I would multiply this thing with 2 by 7, so that 7 and 7 would get cancelled off. 2 would become equal to 2. Okay, the next option that I have is I can multiply 2 with 7 by 2, so that 2 and 2 gets cancelled off. 7 and 7 becomes equal. Okay, now what is the most correct option to be followed? That's the main question. Understand, if I talk about oxygen on the product side, okay, then this on the product side, oxygen is present in form of CO2 and in form of H₂O. Okay, so I don't know that how do I need to split this 2 by 7 in both of them. Okay, I don't know out of 2 by 7 how much should go to carbon dioxide, how much should go to hydrogen, moreover how much should go to water. Okay, moreover there is one more problem. The problem is that if I multiply 2 by 7 on the product side, my carbon and my hydrogen, which I took so much efforts to balance, gets imbalanced. They would definitely get imbalanced. Okay, and I don't want that to happen. Okay, that would be the last possible thing that I would require, so I don't want that to happen. But then if you notice on the reactant side, if you just check the reactant side, on reactant side, oxygen is a stand-alone element. That means he is not combined with anyone. Okay, so what is the best possible option to do? The best possible option to do is multiplying oxygen on the reactant side, and that is what I am going to do. So what I would do over here is I would multiply the oxygen on the reactant side with 7 by 2, and this would be my correct option. This would not be my correct option. Again, I have already discussed why is it so. Okay, so 7 by 2 into 2, 2 and 2 will get cancelled off. 7 will become equal to 7. So I need to multiply this thing with 7 by 2. But then, sir, we can't have a fraction in balancing of chemical equation. I know. Trust me, I know. Okay, so what I will do is to remove this fraction from the picture, I would multiply this entire equation with 2. So that 7 by 2 into 2, the fraction will get cancelled off. The numerators would get cancelled off. Okay, so what becomes my final equation? Let's check. So my final equation, that is, I need to multiply this thing with 2. Okay, this entire equation with 2 I need to multiply. So what I would get, let's check. So what is my final equation? My final equation becomes 2 C₂H₆ plus 7 by 2 into 2, that is 7O2, gives 2 2s, that is 4, so gives 4CO2 plus 3 2s is 6 plus 6H₂O. So this becomes my final equation, and this would be the final balanced equation that I would be looking forward. Just check, let's just check over here. So over here I have 4 carbons. Yes, I have 4 carbons. I have 7 2s are 14 oxygens. So 4 2s are 8. 8 and 6 becomes 14. So yes, I have 14 oxygens. And finally 2 6 are 12. So 12 hydrogens. So 6 2s are is again 12 hydrogens. So everything stands balanced over here. Okay, so that becomes my final balanced equation, wherein I would have a fraction. Let's suppose in the fraction the denominator was 3, so I would multiply this entire equation with 3. If it was 5, I would have multiplied it with 5. If it was anything, any other number, I would have multiplied it with that same number. Okay, but then multiplication is done for the entire equation. So I hope this entire balancing is understood. Again, this is not something that you would learn it just in one day. You need to practice the balancing using many equations. Okay, at least you need to have a practice of somewhere around, I would say, 45 to 50 odd equations that you need to balance, at least for that you need to practice at least for balancing, just to get a sure shot hold on it. Okay, understand that as you move further in this balancing, okay, there will come a point where you no longer require this table to be drawn. This table is only for your reference. Okay, this is only just to right now handhold you, just to introduce the topic. Okay, there will come a point in your grade itself, in this academic year itself, in this probably in this month itself, okay, that you won't require this table. Even if you require this table, it's fine, not a problem. You could always draw this on your rough section and get the answer. It's absolutely fine. At the end of the day, what matters is the correct answer. Okay, so I hope you have understood what is balancing. How do you balance the reactions? Again, you need to practice balancing of reactions more often. I would just pin few of the reactions that you can balance in the comment section or in the description of this video. Try doing it. Till then, thank you students and enjoy learning.